Hello everyone, my name is Solo, and today we're going to be explaining how you can find the intervals in which f of x is increasing and decreasing, and the coordinates of the relative extremas. Cookie
So,
is here to also help with this tutorial.
so first off, the first step you want to do is find the derivative of f of x. So the notation we will use is f prime of x. And so, tell me what rule will we use to find the derivative of x cubed?
We will be using the power rule in order to determine that x cubed would be equal to 3x squared.
Oh, oh, oh.
You could write it.
3x squared. And then 6 minus 6x, the derivative of that. Since the power of x is x to the 1, it will be x to the 0, which leaves that as a constant as negative 6. And 1, since that is x to the 0, it just goes away completely. The derivative of a constant is 0. So our derivative is 3x squared minus 6.
Yes.
And the question is asking in which f of x is increasing and decreasing the intervals of that. But first, let's focus on the relative extremas, which is the easier part of this question. So the special thing about a relative extrema is that the slope at that point is 0, which means that we can set the derivative function equal to 0 to find the coordinates of the relative extrema. So Sols, why don't you do that for us?
So, if we set this to equal to 0, this would then equal 3x squared equals 6. And through division, we could get x squared equals
Equals to
2,
2.
and then afterwards, x equals square plus or minus
Yes, do not
the
forget the plus
square
or
root
minus.
2. That is our x values.
For the coordinates of the relative extrema. And we are not done yet because we have to plug this x value into the original function to get the y coordinate. So we have 2 points. We have a negative root 2, comma, a point, and we have a positive root 2, comma, a point. So why don't you go back to the original function and plug that root 2 in to see what we get?
If we plug the root 2 in, this is going to be a bit of like calculation.
So what's root 2 cubed? Root 2 cubed would be 2 times root 2. So we're going to put 2 root 2, or f of root 2 is equal to 2 root 2, and then we have a minus 6 root 2 plus 1, and this is equal to negative 4 root 2 plus 1. So that's going to be our y coordinate for that one. Negative 4 root 2 plus 1. Oh, no, not that one, not that one. I mean the other one, the other one. The positive root 2 would be negative 4 root 2 plus 1. And now we're going to find f of negative root 2. And that's equal to the same thing, except it will be negative 2 root 2. And instead of it being negative 6 root 2, we're going to do a positive 6 root 2 plus 1. And this will give us 4 root 2 plus 1. So now that we have a coordinates of a relative extrema, we are not done yet because they want the intervals in which f of x is increasing and decreasing. So what we can do here is we can set up a table. We can set up a sign chart. I think that's what it's called.
So yeah, sign chart.
X, y prime, and y. So what I'm going to be doing here is creating a table.
No, don't create a table. Don't create a table. We can just make a line.
Oh, you want to do it that way? My way is like pretty self-explanatory.
Line is pretty easy as well.
Okay, we'll do a line. We'll do a line. We're going to draw a line.
This is the red line.
So let's go draw our 2 x coordinates where they have that thingy, that relative extrema. So we're going to be plugging in points before negative root 2, in between these two values, and after. So tell me a value that's in between negative root 2 and root 2. What's a very easy value?
We should be explaining the purpose of this. The purpose of this is to see if as x approaches negative root 2, whether the x value or the y value would be decreasing or increasing.
So the way we can tell that is if we plug into the derivative function a value that's before negative root 2, if it gives us a negative number, that tells us the function is decreasing. If it gives us a positive number, that tells us the function is increasing.
Yes.
So tell me a value that's very easy in between negative root 2 and root 2.
0.
0. So let's go plug in 0 into the derivative function. Remember, guys, it's the derivative function, not the original function. So when you plug in 0 into the derivative function, what do you get?
You get negative 6.
And that's going to give us a negative number. So that tells us that the function is decreasing in this interval.
Mm-hmm.
Let's go before negative 2. So give me a very easy number that's before negative root 2.
Let's do negative 2.
Negative 2, okay. So when we plug in negative 2 squared is 4. 4 times 3 is 12. 12 minus 6 is 6. And that's a positive number. So that tells us that it's increasing in that interval. Let's go to a number above root 2. So give me a value that's above root 2.
2.
2, let's plug that in. We get 2 squared, 4 times 3, 12 minus 6. That's also a positive number. And we have found the intervals in which it is increasing. So from negative infinity to negative root 2, it's increasing. Union root 2 comma infinity. So this is when it's increasing. And when it's decreasing, it's in between the root 2's. So negative root 2 and root 2. And have we answered the question? Determine the intervals in which f of x is increasing and decreasing and the coordinates of the relative extremas. So guys, do not forget to box your answers. So that's one of our boxes, and this bottom one is another box, and this other one is another box. So guys, our answer is, so the coordinates of the relative extrema are negative root 2 comma 4 root 2 plus 1 and root 2 comma negative 4 root 2 plus 1, and that interval it's increasing at is negative infinity to negative root 2 to infinity, and it's decreasing from negative root 2 to root 2, and I believe we have completed the problem.
I also feel like we should add on whether if this is which one's maximum and minimum for these.
Okay, guys, let's talk about that. So which y coordinate is the bigger one and which one's the smaller one? Let's see. So actually, no, it doesn't matter. Okay, guys, look at the sign chart. Look at the sign chart, guys. So when so you see it's increasing until negative root 2 and decreasing after negative root 2. That shows that the graph will look something like this. So this point right here, that's negative root 2, which means that this is a relative maximum. And we see at root 2, the graph is decreasing and then increasing. So we see at root 2, this is root 2, by the way, that this is a relative minimum. So this negative root 2 comma 4 root 2 plus 1 will be a relative max, and this root 2 comma negative 4 root 2 plus 1 would be a relative min. Guys, even if this number is bigger than the other one, that does not immediately mean it's a relative max or min. We have to look at the behavior of the graph to determine that. Right, Souls?
Yes.
And I believe after that, we have finished the problem.
Thank you for watching.
No, shut up. Now, we will give you guys a problem to do by yourself. So guys, make sure to do this problem. Put the answer in the comments. So we're going to be giving you a function f of x equals. So what function do you want to give them for them to do the exact same problem?
3x to the power of 5 minus 5x cubed.
Isn't that going to be kind of hard to find the zero of? But
not really.
Okay, so this is going to be your function, guys. We want you to find the relative maximums, the relative maximum, relative mins. They're called relative extrema, and we also want to find the interval where it's increasing and decreasing. So now we're going to be playing. We're going to cue the outro, which is going to be accompanied by this. Okay, guys, thank you for watching, guys. Make sure to subscribe, like, and repost for more math videos. Bye, guys.
Bye-bye.